Hi, welcome to part 2 of the prediction path tutorial. So in the last one we got all of our functions and variables and blueprints created that we're going to need. So all we have to do now is start filling out the blueprints. So let's go ahead and start over here for when the right mouse button is pressed. So when the right mouse button is pressed, we want to start drawing that prediction path, and then when you release it, we want to stop drawing that prediction path. So to do that, we can just drag in our create prediction spline and hook that up to pressed. And then when you release it, we want to call destroy prediction spline. And again, make sure you choose destroy prediction spline and not the other destroy prediction meshes, because we're going to be using that one for something else. And so let's go ahead and write each of these functions. So let's come inside of create prediction spline. So inside of here, basically what we want to do is we want to create the spline itself. And then we also want to create that little endpoint, or that little sphere at the end, because we're going to be showing that as needed. So let's just right click and say add spline component, and make sure you hit this one down here, not the top one. So add spline component. And then we want to save this variable. So we already have a variable for it, which is our prediction spline. So just drag that in and say set and hook that up. And so that's our spline. And then the next thing we want to do is we want to spawn our endpoint. So right click and say spawn actor from class. And the class we want to create is our BP underscore prediction endpoint. And then the spawn transform, if you try to compile it right now, it's going to give you an error because it says you need to specify this. But if you just right click and split it, then it will split into its individual parts. And if you compile, then it's totally fine. So just do that because we're going to be moving it later, so we don't really care where we spawn it at. And we want to save this. And again, we have a variable for that. So let's just drag in our prediction endpoint and say set. So hook that up. And then finally, we want to tell this guy to be hidden because by default, we don't want this to be shown. Because if you remember, I'll run my other project again. You remember? So that I'm talking about that little sphere at the end there that shows where it's hitting. But if you're not hitting anything like I am right now, then you don't want it to draw, or at least I don't want it to draw. So by default, we're going to say that it's hidden, and then we're going to show it only if it hits something. So if you just drag off of this and say set hidden or set actor hidden in game, we want to just leave this as false. So that's the creation of our spline. And that's really all we need to do here. So if we come back to our event graph, the next thing we want to do is write our destroy prediction spline. So let's come in here. So we only want to destroy our prediction spline if it actually exists. So just as a precaution, let's drag in our prediction spline and say get. And then you can actually right click on this node and say convert to a validated get. And what that will do is we'll give you these is valid and is not valid. So you can check whether or not it's valid. So if it is valid, we want to say destroy component. And then we want to set it to nothing. So drag in the prediction spline again and just say set, and then just leave this empty, and that will set it to nothing. And then the next thing we want to do is we want to destroy our prediction meshes. Now, we haven't actually created these yet, but again, these are just the meshes that represent the line itself. So whenever the spline gets destroyed, we want to destroy the meshes with it. So let's drag this guy in and say destroy prediction meshes. And then we also want to destroy that little endpoint as well. So we will say drag in our prediction endpoint and say destroy actor. And then just like we did for the prediction spline, we want to set this to nothing. So drag in, again, the prediction endpoint and say set, and just leave it empty. So just set it to nothing. So again, this is just destroying the spline, destroying the meshes that make up the spline, and then destroying the little endpoint. All right. So now let's come back here to our event graph. Or actually, maybe we should write this one because we haven't filled out this function yet. So let's do that next. So destroy prediction meshes, let's come in here. So this is going to be pretty straightforward. So we have our prediction spline meshes here. So let's drag these guys in. And again, we haven't filled these out yet. We will do that next. But basically, again, just to keep reiterating, all this is just an array of the meshes that make up the spline. So what we want to do is we just want to loop over these since it's an array. So we'll say for each loop, and we want to destroy them. So we'll just say destroy component. So that will destroy them all, but then when it's finished, we want to empty this array. So let's drag in our array again, and we'll say clear. And then we'll hook that up like so. So it destroys all the components, and then it clears them. All right, so now if we come back here to our event graph, we got this part written. The next thing we can start writing is the event tick, because that's where we're going to actually handle rendering our spline or our prediction path. So for the event tick, we want to hook up the draw prediction spline, like so. And then we'll go ahead and start filling out this function. So this is where the majority of the code is going to live inside of here. So let's open this guy up. So the very first thing we want to do inside of here is we want to make sure that our prediction spline is currently valid. Because if it's not valid, then obviously we can't draw it. So that's what we have this macro here for. So let's drag this guy in. We need to write this macro first. Let's just go ahead and write all these macros because they're going to be pretty straightforward. So for the prediction spline valid, let's just double click on this. All this is going to do is just, you really don't even need these macros, but I just find them easier to make than to not make because they kind of keep the code cleaner. So for this, we just want to say prediction spline get, and then we'll say is valid. And we want to use this one with the question mark here because we want the little pins. And we'll hook that up, and that up, and that up. That's all we need to do there. We'll write the other ones later when we come to it. So let's come back here, and we can say prediction spline valid. And so now we just have a handy little macro that tells us if it's valid. And so if it is valid, then we actually want to do stuff. So we want to do two things. We want to first add the points to the spline, depending on where the path, like where we predict that the projectile is going to go. We want to add points to it. And then the next thing we want to do is we want to take each of those points and we want to add a mesh at that point so we can actually see the points and we can see the whole spline. So since we're going to be doing two things, let's add a sequence node. You can do that by holding down S on the keyboard and then left clicking. It will create a sequence. You can also create it by right clicking and searching for sequence. But I use the little shortcut because it's faster. So again, the first thing we want to do is we want to figure out the prediction path of where this grenade or where this object is going to go, and then we want to add to our prediction spline each of those points. So there's actually a handy little node inside of Unreal that tells you the prediction path of something, and it's called predict projectile path, and there's 3 of them. The one we're going to be using is the trace channel. The other ones just have some slightly different options, and advanced obviously just has a bunch of options, but we don't really need that. We can just say by trace channel, so we'll select this one and hook that up to the then 0. Now the starting location and the launch velocity, these are the starting position and the launch velocity of where we are going to be throwing the grenade from. So that's why I made these little macros over here. But in order to fill these out, we need to do something first because we need to figure out where we want the grenade to spawn from. Because we could spawn it like right at the camera's location, but in most video games, when you throw a grenade, it doesn't just come directly out of the screen. It comes like a little bit from the left or the right because it's, as if you're throwing it with your left or your right hand. So to emulate that, we can go to our viewport tab, and then up here we can say add component, and we can add a scene component. And then we want to take this scene component and drag it onto wherever your camera is. So we're going to drag it onto our first person camera, and that will parent it to the camera. So whenever the camera moves, this will move with it. And then let's just call it like throw transform. And then we can take this and just drag it to wherever we want the grenade to come from. So I think in my tutorial at the beginning, I had it coming from the left side. So we'll say like right here. And then you can also rotate it. So if you want to rotate it up like this, it will now come out at this angle, wherever the red line is. So it'll go like up and then it will drop off. So you can rotate that or put it however you want. But that's basically where the grenade will spawn from and at what orientation it will spawn at. So now that we have this, we can come back to our, where were we? We were inside of draw prediction spline. We can come back here, and so we need the start position and the launch velocity. So the start position and the launch velocity are both going to be derived from this throw transform. But we're going to put them inside of these macros because it just makes the code a little bit cleaner, because we're going to be reusing these in more than one place. So let's do the location first, because that one's pretty straightforward. So double click on this guy, and what we want to do is we want to drag in our throw transform. We want to say get world location, and we just want to return that. So we're just saying basically, you know, we want to spawn this thing at wherever that throw transform is. And then for the throw velocity, it's going to be a little bit more complex, but still really simple. Again, we want to drag in our throw transform, and we want to say get forward vector. So the forward vector is going to be this red line. So if you remember this red line, so we're getting this red vector right here, because that's the direction, at least, that we want to throw it in. So we want to multiply that by the speed. So we can say float multiply, and then we have a variable over here that we made earlier for the throw speed, so multiply it by the throw speed, like so. And then that is going to be our velocity, because velocity is a direction multiplied by a speed, just like this. And then we might want to set this throw speed to something, so if you click on it, make sure you have things compiled, click on it, and just set it to something by default, like 2000 is probably good, just so it's not 0 by default. Now we can come back here to our draw prediction path, and we can just drag these in. So the start position is going to be our throw location, and the launch velocity is going to be our throw velocity. And then the projectile radius is going to be depending on how big the radius of your grenade is. So if you remember from the beginning, we scaled it down by 0.25, and by default it was 100, so that means it's going to be a size 25. You might want to find a better way to get this, like you might want to check which grenade you're holding and then get the size of it and then use that here, but you basically just want this to be whatever the size of the grenade is that you're going to be throwing. So in our case it's 25. And then if we hit this little drop down here, well, actually we need to fill this guy out, so we want to tell it to ignore the player, because obviously we don't want the grenade to hit the player as soon as it spawns. So we drag off of this, drag over this and say make array, and then we want to pass in our self, so right click and say get self reference, and hook that up like so. And then we can turn on these draw debug times for now, because it will kind of help us. So let's change this to 1 frame. And then these values we can tweak later, so I'm just going to leave them right now till we can have it set up so I can show you what they actually do. But this should be good for right now. So what this does is this returns to us an array of the positions along the path of where the engine thinks it's going to go based on what we told it here. So what we want to do is we kind of want to do two things. We want to check if it hits something, because if it hits something, we need to draw that little sphere at the end of it. But if it doesn't hit something, then we don't want to draw that sphere. So that's one thing we need to do. And then the other thing we need to do, regardless of if it hits something or not, is we need to fill out our prediction spline with these points. So let's drag off of here. So this return value basically just is true if it hits something, and if it's false if it's not. So we're going to do a branch. And if it did not hit something, then we want to make sure that our endpoint, so that little sphere at the end, is not visible still. So we can drag in our prediction endpoint and say get, and then we can say set actor hidden in game and set it to true, because again, we didn't hit anything, so we don't want to show the endpoint. Let's put that here. And if we did hit something though, we want to set it to true. So copy and paste this. And then I'm trying to organize this somewhat nicely. And then we want this to go up here, except this time we want to set it to false so that it's visible. And then if it's visible, then we also want to set its location to wherever it impacted at. So to get that, we need to get this out hit result. So drag this up here and say break hit result. And then we're going to need to hit this little drop down button so we can see everything. And we want to use the impact point, because this is where the prediction path hits something at. So we'll copy this guy and we'll say set actor location. And the location is going to be, like I just said, the impact point. Make sure you select impact point and not one of these other variables like impact normal, because pretty much 9 times out of 10, somebody has a problem with this break. It's because they did this and not impact point. So please make sure you're dragging off of the impact point. So impact point, and we can just hit teleport because we just want it to teleport there. And then, so that's the first step, is showing or hiding that in location. And then the next thing we want to do is set the spline points. So drag in our prediction spline, and we'll say set spline points. And we want to hook this up to the top and the bottom because we want to do this regardless of if it hits something or not. And then the points is going to be these points. So you can just drag this guy over here. And I'm just going to clean it up a little bit, like so. And then this is all in world space. So we want to make sure we change the coordinate space to world space. And then finally, we want to destroy the prediction meshes. And the reason we're going to do this next, so let's just hook that up real quick. So the reason we need to do this is because, if you remember, so this is inside of the tick. So all this is getting ran each frame. So just kind of recap what we're doing here is we're getting the prediction path, which is just an array of points. And then we are setting those points. And then we need to destroy the old prediction meshes for where the line was last frame, because we're about to add new ones. Because if you're turning or something, you don't want to see the prediction path from last frame. You only want to see the prediction path from this frame. And so we want to destroy the old meshes because we're about to add the new ones. And again, we already wrote this function, remember, from before, so we don't have to do anything, so we can just continue. So that's our first step. So let's drag this over here a little bit so we have some room to drag off that sequence node. And we can actually probably run this at this point just so you can kind of see what's going on, I think. Yeah, if we go ahead and run this and we hold down right click, you can see it is drawing our prediction path. So it's drawing spheres to represent the prediction path, and it's also drawing that little red sphere at the end. But it only draws it if it's actually hitting something. So that's what it should look like. If it doesn't look like that, then go back and rewatch this part 2 to make sure you have everything set up correctly, because basically all we've done is, just a couple functions. So if you messed up, it should be pretty easy to figure out where you messed up at. But if you haven't, then just keep watching. And the next thing we're going to be doing is adding the meshes. So you can see right now, it's just, these spheres are just debug spheres. But we want to replace these debug spheres with actual meshes to represent the line, because we don't want to draw debug spheres because they look bad and they're really expensive. And they won't even show in your final game, so lose, lose, lose. Okay, so to do that, we need to draw it based off of this prediction spline, which we just added points to. So down here, we want to do a for loop, because we want to loop over each of those spheres, I guess you can think of. We want to loop over each of those spheres and replace them. So we're going to say for loop. Well, actually, we're not really looping over the spheres. We're looping over, it's kind of hard to explain, because the spheres are just like a random distance apart from each other, so we're not really looping over them. We're looping as many times as we need to cover that whole arch. It's a better way to think of it. So we want to drag this down here, or then down to here. So the amount of times we want to loop is going to be equal to the length of the spline, which is the length of the entire arch, divided by the size of an individual mesh inside of it. So we can say get our prediction spline, get spline length. So this will get us the whole length of the spline, which is like the whole length of the arch. And we want to divide that, so we'll say float divide by whatever the size of is our mesh that we want it to represent, or that we want to represent. So we're going to put 100 here, and I'll show you why. So the spline that we're going to be using, the mesh that we're going to be using inside of the spline is going to be a cylinder. And it's going to specifically be, if you go to the starter content, and you go to meshes, or maybe shapes. Yeah, so if you open up this shape cylinder, we're going to be using this guy. So it's going to be a bunch of these guys like stacked on top of each other to represent our arch. And if you look up here at the top left, it says the approximate size is 100 by 100 by 100. So we need to use 100 because we really only care about the z-axis, because it's going from the bottom to the top, and the z is 100. They just all happen to be 100, but we really only care about the z. So if you're using a different mesh, you need to make sure that you use the length of the actual mesh, and this is how you can check it. So we need to use 100 here. So that's why I'm using 100. And that's going to be our last index, and it's going to truncate it, which is fine. So we're in from 0 to that. And then we want to promote this to a local variable just to make things easier for us as we do this loop. And we will call this the index that we're currently on. Okay, so for each one, for each iteration of the loop, we want to create a spline mesh. So we'll say add spline mesh component. And then we want to set manual attach to true because we're manually going to be attaching it ourselves. Actually, do we need to do that? Now that I think about it, let me run my other project. No, we don't need to do that because, yeah, hold on. I just got a bunch of errors. Let me uncheck that. Give me 1 second. I'm just testing something. Yeah, we do want manual attach because we aren't actually attaching it to anything, so we don't want it to manually, or we don't want it to automatically attach for us because we don't want it to be attached to anything, which is why we're checking that. I know it's kind of confusing, but we don't want it to be attached to anything, so we're checking it so that way we can not attach it to anything. Okay, so that creates the actual mesh component, and there's a few things we need to change. So we want to use that cylinder, so we'll say shape underscore cylinder. And then we can also change the material type to be our M underscore prediction path material, which is that red material that we created. What else do we need to change over here? We don't want any collisions. We can uncheck overlap events. We can set this to no, and we can set that to no collision. I know there was something else. Yeah, you need to set the forward axis. Okay, so you need to set this to Z, and the reason we're setting this to Z is because you need to tell it how you want the shape to be oriented. So again, if you come back and you look at here, we're telling it we want to use the Z-axis because the Z-axis is from bottom to top. So we're saying we want it oriented from bottom to top so that it's facing along the Z-axis. If you don't have that set, I can show you what it looks like, but it won't look correct. I think that's everything we need to set here. We might need to change something later. I might have forgot something, but for now, this is good. And so now that we have it created, we want to add it to our array of prediction spline meshes. So drag this guy in and say add, hook that up, and hook that up. And then finally, the last thing we need to do here is we need to set the actual location of this spline. Because if we run it right now and we hold down right click, you can see, well, it is creating the splines, but they're being created at some random location, probably at the origin, if I had to guess, because we haven't actually set the position of them yet. So that's the next thing we need to do. So if we make a little reroute node here, there's a function called set start and end. And this is going to get a little hairy here because the math is kind of complicated, but I mean, it's really nothing we have to do. The engine does it for us, but it's a little complicated to explain. So we need to fill out all 4 of these, the start and the end position, and then these tangent values as well. So to calculate them, we need to calculate them based off our spline. So let's drag in our spline. And there's actually handy little functions here. So you can say get location at distance along spline. So it's going to get us obviously it's going to get us the location at whatever distance we pass it along the spline. So the distance we want to use is going to be whatever our current index is. So let's drag in our index and multiply it by the size of an individual mesh, which again is just 100. And that's our distance. And we want to make sure we change this to world space because we're doing everything in world space here. And that is going to be our start position. And then for our end location, we want to do basically the same thing, except we want to do the index plus 1 because we want the next element. So I'm just going to copy this. And then this time we're going to say index plus 1. So we'll say int plus integer. So int plus 1. Hook that up, and that will be our end position. So now if we run this, we haven't done the tangent yet. We'll do those next, but just you can kind of see what's going on. So if we run this, and we hold down right click, well, you can kind of see it. I need to move this over a little bit. Also, I think that cylinder is way too big. So let's change the cylinder. Oh yeah, that's one of the things I forgot. So yeah, if you click on the add mesh component, let's change this guy. If you search for scale, You can change the X and Y scale. Let's set these to like 0.1, so that way it's not so thick. Compile, save. And so there. So now you can kind of see it going on. If it's really laggy for you, that's primarily because of the debug spheres. Like I said before, they are extremely bad on performance. But anyways, you can see we have some holes, and it doesn't quite look all that great. Let's go ahead and hide those spheres because we don't really need them. So you can set this to none. You can kind of see what's going on. So we have some holes, and you can kind of see all the individual pieces. It doesn't look that great, and that's primarily because we need to do the tangent thing. So let's figure out the tangent value. So there's a handy little function for that as well. I'm gonna move this guy down here a little bit more. So if we take our prediction sphere again, and we say get tangent at distance along spline, and again we want world space, and the distance is going to be the same distance as before. Come on, it will return our distance, but we want to make sure that we clamp this we clamp the vector size between 0 and 100 so it doesn't scale horribly on us. So we'll say clamp vector size 0 and 100 because that's the size of the mesh, and we'll hook that up to the start tangent. And then the end tangent, we want to do the same thing. So we can just copy these guys, paste it down here, hook that up, and hook this up to the end tangent. So now if we run this, and we look, we have this nice, smooth looking line. And you might want to adjust the where was I? You might want to adjust the throw transform a little bit. Maybe it's a little too close. Start it out there, something like that. So there we go. So now we can see our throw transform. Oops, that was really loud. And it's currently just using 2000 as the speed because that's what we hard-coded it to. But we want to change that so that we can make it editable via the mouse wheel. So if we come back here to our first person character and we go back to our event graph, and we have this little mouse wheel. So inside of here, we can write a little bit of code to make it so we can change this throw speed. So when the mouse wheel is like scrolled up or down, this will get, well, actually it's called all the time, but normally this value is just 0. So if you ever move the mouse wheel, then this value either is like positive something or negative something. But we only really care about this if you're currently holding down the right mouse button, because otherwise we don't want to change the throw speed. So we can use our prediction spline valid node to say, only do this if we're actually if the prediction spline is valid and we're trying to throw something. So if it is valid, then we want to take the throw speed and we want to add, so float plus, we want to add this axis value to it, except we don't want to just hook this up because this axis value is just going to be a really small number. I think it's between -1 and +1. So we need to multiply it by just whatever value you want. It doesn't really matter, but whatever value you put here is going to be like the speed at which the mouse wheel moves it's kind of like the sensitivity of the mouse wheel, I guess you can think of it like that. So I'm just going to set it to like 100 or something. Again, you can tweak that value. You can see what it does pretty easily when you tweak it. Then we want to take this and we want to clamp it. So we'll say clamp float because we don't want the velocity to go like to 0, obviously, because who wants to throw a grenade with 0 velocity? So say like 600 is the min and like maybe 3000 is the max. And then we'll set the throw speed to that. So now if we run this and we hold down the right mouse button and we move the mouse wheel, you can see it adjusts accordingly. And when we let go, it goes away. So the final thing we need to do is make it so if we hit the left mouse button, because right now it just fires, and I'm not going to do it because it's super loud, I should probably turn that down. But we need to change it so that if we press the left mouse button while we're holding down the right mouse button, it throws our grenade along this path. So to do that, we can come up here to the fire. So this is just part of the template. It comes with the template. But fire is bound to the left mouse button. So we're just going to edit this to say, only fire if we're not currently holding down the right mouse button. So I'm just going to delete this touch thing because I don't even care about that at all. So let's drag this over here so we have some space. So again, we're going to drag in our prediction spline valid. So if our prediction spline is valid, then we don't want the gun to fire when we left click, so we want to drag off of is not valid and hook that up to wherever it was hooked up before. So again, if it's not valid, then do whatever you want to do for firing. We want to do that on pressed, and then on released, we want to check if the prediction spline is valid, because if you release the, actually, does that make sense? I guess we probably want to do pressed for both. So yeah, if it is valid, then we want to do the grenade throw. So when we throw a grenade, the first thing we want to do is we want to destroy the prediction spline, because when you throw the grenade, you want the prediction to go away because you threw the grenade. So we'll hook this up to the is valid. Maybe this should go up here to make more sense. We can fix it later. So yeah, destroy the prediction, and then we want to actually spawn the grenade. So we'll just say spawn actor from class, and if you remember from the beginning, we made that grenade, so we'll just say BP grenade. And then the spawn transform, we can just split this guy. The spawn transform location is going to be our throw location. Okay, I guess we have to drag that in and then hook it up. And then velocity, you remember we made this variable like way at the beginning inside of our grenade. I'll just show you if you forgot. So if you go to your grenade, remember we made this velocity and we said inside begin play, we're going to set the projectile's movement velocity to whatever velocity that is. So that's why you can see that velocity there. Oops. How did I didn't even know that was a thing you could do. I don't know how I did that. Okay, hold on. Oh gosh. Oh, okay. We're back to how we were. Sorry. I've never done that before. I didn't know you could do that. So the velocity is going to be our throw velocity, so we'll hook that up. And that's really all we need to do, because the grenade class is going to take care of everything else for us. So now, and I'm going to go over here and change down this volume because it's so loud. I'm just going to say like 0.1. Okay, so now if we play and we left click, it fires, but if we right click and then we left click, oh, it throws our grenade, kind of, but something's not right. It's not destroying our... Oh, that's because we said create projectile spline. I meant to say destroy projectiles or prediction spline. That should work a lot better. So now if we left click, you can see it throws it, and it throws it right along that path. So if we make it smaller, and it hits pretty accurate to where our thing is. Boing. Like so. So yeah, I think that's pretty much everything for this tutorial. If you enjoyed the tutorial, please leave a like and subscribe. I also have a Patreon. If you guys want to support me on there, I'd really appreciate it. It helps me keep making tutorials. I also have a Discord channel. The link is also in the description. If you have questions or you just want to come hang out, feel free to join it. Otherwise, I will see you guys in the next tutorial.